practical than a car crash is playing pool. But still, pool is a really good game for physics. In fact, I mean, I grew up having a pool table in my basement. It seems like everything costed $100 and was bought from an uncle in my life. But honest to goodness, this was bought from a different uncle than I bought my car from for $100. And it existed in my basement for all my teenage years, and that was my pool table where I learned how to play snookers and billiards, and I would have all the guys over, and every once in a while I got a piece of plywood that was cut the same size as that pool table. Every once in a while we would play a giant game of poker on that table, and we only played with jelly beans because we couldn't afford to lose anything other than that, and each jelly bean had defined values just like poker chips. It was a delicious way to learn how to gamble, I suppose. Anyway, that's all bad stuff. But we did have a good time around the pool table. Find the final velocities of the two pool balls if they both have a mass of 1.55 kilograms and ball A is initially moving at 2.35 meters per second. Now, 1.55 kilograms, not a regulation pool ball. But all the pool balls should have the same mass. We want to have pool balls that have matched masses. If you've ever tried to play billiards and have mismatched balls, it's wonky. They have to be from the same set, otherwise things don't collide and careen off properly. They have to not only be the same mass, but the balls themselves have to be the same diameter. You can imagine a sphere hitting another sphere on a level surface. If one diameter is smaller than the other, then the contact point's going to be below the center of mass for one of those two balls, and there'll be some jumping balls. That's a whole nother issue, right? So they got to be matched masses, matched diameters. So pool is really controlled in that way. I've got a reference frame here. For no particular reason, north is negative and south is positive, and west is positive, really because ball A, the cue ball, the white ball, is moving towards the west first. So I'm going to put an A in the middle of that one, even though I'm just telling you that's mass A, but mass A goes off over here, and I can't tell if I can't zoom in close enough. My eyes are failing me. Can you guys tell that I turned the 8 ball into a B ball? This is my high-end graphics. So as I look at this 1.55 kilogram mass, not 155, that would be massive balls. 1.55 kilogram mass is moving off at 2.35 meters per second. What we've said before is that momentum is going to be conserved. So I'm going to first think about px being equal to px primed. And if I expand that out, that means that ma vax plus mb vbx equals ma vax primed. I'm definitely going to need some people to help me with the calculators on this one, because this is going to be a thing. Plus mb vbx primed. And then I realize, I mentioned this once before, that buried under the hood of VAX primed and VBX primed are some thetas. So I want to take a look at this first one. First of all, what can I zero out? Can we agree that ball B isn't moving initially? Let's get rid of that. Because I'm not going to go full generalized equation on this one. It's just going to be too much. Okay, so I'm going to zero some things out right away. But I also recognize, before I go any further, that I could expand out the VAX primed and the VAX. So I could write it like this. MA VAX. I guess I don't have to expand that out because it's just going straight west. But when it comes to the afters, MA VAX primed, man, that's going to be VA primed times cosine. I could put it on as cosine, sorry. I could put it on as cosine of theta, but I already know the value, it's 40 degrees. So just so we don't lose track of things, I'm going to write it as 40 degrees right now. Plus MB VB primed, and I'm writing VB primed, not VBX primed, times cosine of 31. 0.1 degrees. In terms of reference frames, notice that A and B are both traveling off to the west-ish. So their x components are both positive. So I'm just acknowledging that right now, but that I've left both of those values positive. I haven't forced in a negative sign because the reference frame says that they're traveling to the west, and to the west is positive. So we want to choose our reference frames appropriately. I think, and I never do this, I always isolate for a variable first, but you'll see why in a minute. I think I'm going to sub in my values now. Also, I'm going to do something that I never do. I'm going to drop the units. And for this particular question type, you guys can drop the units as well, okay? That tells you how serious this is. I'm doing two things I never do. Sub in before isolating and drop the units. So 1.55 is that mass times 2.35 meters per second equals 1.55 for this mass, VA primed, times cosine of 40 degrees, plus 1.55, oops, missed my decimal place again, kilograms times VB primed, times cosine of 31.1 degrees. Now I'm at a situation where I've got a VA primed and a VB primed, but they're surrounded by numbers. And just recognize that I can collect the numbers, like that 1.55 and this 1.55 can multiply times the cosine 40. So what I'd like to do is, it's not really distributive property, it really is just multiplying through a single expression. But can we please do this? 1.55 times 2.35, 1.55 times cosine 40, 1.55 times cosine 31.11. We need to get some coefficients here, okay? So the coefficients that I come up with, and I did pre-do this one because I want to make sure that we can work through it reasonably expediently. 3.6425 equals 1.187369 VA primed. And you can check my numbers, please do. Plus 1.3272 VB primed. Okay? And the reason that we've done this is because, and I'm going to put a 1 out front, the reason that we've done this is because this produces a linear equation with two unknowns. And although this isn't the linear equation that we would like to see from grade 9 math, it is just a linear equation. Okay? Now I want to think about y information. Py equals py primed. And I want to expand out my y information. Now, before I do that, can we all acknowledge, isn't py equal to 0? Okay, let's do that, okay? Let's write the 0. I'll stroke out the py. It's 0 because there's no y component. 0 is equal to, and we'll expand out py primed to be, I'm leaving a little gap here after my equal sign because I want to revisit something to do with reference frames. MA VA y primed plus MB VB y primed, and this spot that I've left blank, can you guys notice that north is negative? So there's got to be a negative sign that I got to put in here. This is for reference frame purposes, okay? So I'm just going to make a note to myself, just because it's a lesson, to say that that's in there because of a reference frame. It doesn't come in there unless you can recognize that as a human brain. But then we expand this thing out as well. We say, okay, 0 is equal to negative MA. Instead of VA y primed, I'm just going to say VA primed times sine of 40 degrees plus MB VB primed sine of 31.1 degrees. And we can expand it further. 0 equals, and I'm going to do that same old thing. I'm subbing in my values, and I'm even dropping the units. Minus 1.55 VA primed times sine 40 degrees plus 1.55 VB primed sine 31.1 degrees. And I'm going to do the same maneuver as before. We're going to collect up our coefficients. And I would invite you again, make sure that I don't make a mistake. I've got my negative sign out front, but 0.9 0.9632 VA primed plus 0.800627 VB primed. And I'm going to put a box around that. I'm going to call it equation 2. Now, if I want to figure out the final velocity of the two balls, I've got two truly linear equations now. This is going to let me figure out their speeds. I know their directions if I'm looking for velocity, but I got to find their speeds. So, if I take equation 2 and I isolate, I want to get VA primed all by itself. VA primed all by itself, you could probably do this in your head, ends up being negative 0.800632. Did I get that right? No. What am I doing? I took the tail end of the previous one and added it on where it didn't belong. 627. 627 VV primed divided by negative 0.99632. Now the negative signs are going to cancel each other out, so I'm not worried about that. I get VA primed equals 0.803583 VB primed. What would I do with such a thing? I've gotten this from equation 2. What am I going to do with it? Yep. I love it. So sub into equation 1. So if I'm going to sub this guy into equation 1, here's my equation 1 revisited. 3.6425 equals 1.187, 7369. Times 0.80. You can see why I dropped all the units, eh? There's a lot going on here. 803583 VB primed plus that 1.3272 VB primed. Now if I multiply through and collect the like terms, I got to multiply this guy by this guy, then I can collect my like terms. I end up getting 3.6425. Now this, I'm kind of doing these steps for you. I'm not pausing for you to calculate because this is just mechanics. This is something that we should be able to do. I wouldn't call it, just like child's play, but it's not big new ideas, right? I'm just going through the process of collecting like terms, isolating VB primed, and then finally getting a value for VB primed. 1.596633 meters per second. And I'm not rounding that off yet. I'll do that like at the end. But I've got a speed now for ball B. And people say, really? Do people go this deep into pool calculations? Well, maybe not billiards, but can you imagine these balls that are like solid things that are hitting each other and ricocheting off of each other? Can you imagine this being a stand-in, intro to particle physics collisions? Like alpha particles hitting radioactive nuclei or something like that. This could be, like a precursor to that. So when you break up a bunch of balls, you got them all racked up and you're about to play pool. Can you see how this could be like a particle collision? Nuclear fission process getting started. So we're laying the foundation, okay? I know it's not really about pool. It's about something else. Anyway, equation 3. sub VB primed into, oh, you know what? I didn't define equation 3. Equation 3 is this guy right here. Let's just backtrack. We should define this guy as equation 3 because it's such a handy little one that we should go back and use it. Look, I can sub in VB primed into this one and get VA primed right out the other end. I know it's really just equation 2 primed. But sub VB primed into that equation 3, and we end up getting VA primed equals 0.803583 times 1.596633. Which works out to 1.283027 meters per second, or approximately, maybe I will round it now, 1.28 meters per second. And we had a direction for it too. It was west 40 degrees north. VB primed. VB primed was rounded off 1.60 meters per second. West 31.1 degrees south. And so yeah, it took a little bit. In the end, it's really just linear equations, but unpacking linear equations in like sort of a complicated way, I guess. Now, question B for this is to determine if the energy has been conserved in the pool ball collision. So let's check, okay? Obviously, pool balls don't stick together, so this is not a perfectly inelastic collision like the car crash we were looking at earlier. But we could check EK total versus EK total prime. And we could do this as a left side versus right side. I'm just going to do it as like a before and after, mostly because my page is getting narrow and I can't fit a left side and a right side. But EK total is equal to 1/2 MA VA squared plus 1/2 MB VB squared. And we sub in our values. VA was 2.35 plus, and actually since VB was 0, it's just plus 0. And please check my numbers, but I get 4.2799 joules, approximately 4.28 joules. But then when I run that against my EK total prime, let's see what we get. So 1/2 MA VA prime squared plus 1/2 MB VB prime squared. I'm all ready to just plug in my values. VA primed unrounded, oh gosh, was equal to 1.283027 meters per second squared. Looks like I'm going to have to wrap around to a second line. And VB primed unrounded was 1.596633 meters per second, all squared. And I get 3.25143 joules, approximately 3.25 joules. And we could say, was energy conserved? No, but if you've ever played pool, you know that the energy is going to get dissipated into the environment by the sound of a loud smack when those balls get hit together. So that's the most likely place where the energy is going. Probably there's some vibration of the balls, maybe some thermal energy as well. So energy is lost in this partially elastic collision. And if you were determined to really numerically analyze this, we could do a percent efficiency calculation. Energy final over energy initial times 100%. I don't feel like I'm not determined to do that right now, but we could do it.